This is the cause for so much pain and misery for new JavaScript developers. In this lecture, I'll teach you all about functions and this in a way that actually makes sense. So let's break down functions and this, which is probably one of the most misunderstood pairs in JavaScript. In this lecture, you learn about different ways of declaring functions, especially how this reacts with all those functions, and how do we change the context using call, bind, and apply. Let's start off simple. You can create function in two main ways. One is using the function keyword and another using the arrow syntax. Now, syntax aside, they look kind of similar. They both can take arguments, both can return values. You can also pass them around and store them in variables, all of that. But the key difference here is how they handle this and args. But we are not concerned about arguments right now. Let's start off with a normal function defined using a function keyword. Let's head over to the editor. Let's start off with a normal function defined using the function keyword. And let's console.log something. Let's print out something. To call this function, we simply say example func, the name of the function, and parenthesis. This will execute everything that is inside the function. On the right, we can see it did exactly that. This is how functions work. Let's understand how functions react to this keyword. So if I console.log this over here, let's see what happens. You see, I'm getting the window object. This is a special keyword in JavaScript which tells you in which context a function is running, or to put it more simply, which object is calling the function. In here, the example func, it's being called on the global context. So in this case, since I'm running it in the browser, I will get the window object. You can see here I'm getting the window objects. This is the default global object that we have when we are running JavaScript inside of a browser runtime. If I expand that, you would see it has a lot of different properties and methods in it. We won't be concerned about everything. The ones that are important to you might be the document object that we use a lot, and some other objects like alert. If I come up here, there's an alert function. So these are the few functions and methods that we use on a daily basis when working with JavaScript on the browser. So as you can see, we are getting the global object. The keyword this is dynamic and is determined at runtime when the function is run. When we are running this function, that's when this gets the value. Here we are running it without any object. On the left hand side, we don't have any object. That's why it's getting the global object when we log this out inside the function. When a normal function is run, it creates its own context, the function execution context, which determines this based on the object the particular function is attached to. If a normal function is called without being attached to an object, this inside it usually refers to the global object, like the window in the browser or global object in Node.js, unless we manually change the context using call, bind, and apply. Now the question arises, what if the function is attached to an object? Let's create an object and add a method for reference. Let's have a const person object. The name would be, let's have a method in it, what's this inside, and refer it to the function that we just created, example func. Note that there are no brackets here. I'm not putting parentheses over here. We are not calling the function but referencing it. That means whenever I call this what's inside from the person object, it will refer to the function here that we have defined, example func. To call this function, you would say person dot what's this inside. And call it using parentheses. And boom, here we go. we have our this context changed. Although we are running the exact same function, our this context changed. Amazing, isn't it? Depending on which object is calling the function, this is changing, demonstrating the dynamic nature of this when using inside normal functions. Let's go one level deep and see what happens. Let's create an object inside an object. And inside that, let's create another object. In here, we'll create the method that will reference to the function. And then again reference to the example func. So this time if I want to call this function, if you want to call this function, you would have to say outer object dot inner object dot what's this inside parenthesis. Dot inner dot what's this inside. In here, what do you expect? Which is the object that is calling this function? We are getting the inner object that is calling the function. That means on a general note, we can say whatever is on the immediate left hand side of the function that is being called is the this for that function. In our case, the inner object became the this for the example function. This is only dynamic in case of working with normal functions. We'll talk about arrow functions a little while later. In general, what we can say is when we are working with normal functions, whatever is on the immediate left hand side that is calling the function becomes the this inside. Let's take another example. You have another person whose name is Tom and he says hi. Let's create it a normal function and console.log. It says hi, I'm the person this dot name. So if I say person dot say hi, I would expect this inside the function to be the person object itself. So person has a property name. When you say this dot name, then we get Tom. Let's see that in action. And here we go. Hi, I'm Tom. So far so good. We get hi, I am Tom because when you call the function as a method on an object, this refers to the object before the dot. In this case, the person object itself. But now let's mess with it a little. Let's introduce a callback. Let's say set timeout. Now inside this function, we'll run a set timeout. And set timeout will take in a function which will log this out. Let's have a timing of certain seconds. 1 second. Okay, what do you think that prints? Hi, I am Tom. We are doing the same thing but inside an asynchronous set timeout function. Let's save that. What do you think that prints? Hi, I am Tom? No, it prints hi, I am undefined. Let's change that to f name. So if I say this dot f name, now it says hi, I'm undefined. The function that you passed in the set timeout is a regular function. Remember, whenever we are calling the function, this refers to the object who is calling the function. In this case, we are not manually calling the function that is printing this out. That is handled by set timeout and that is happening in the global context. The global object is calling this. That's why I'm getting hi, I am undefined. So if I just print this over here, you would see window object being printed. Hi, I'm object. So window. Let's change back this to fname dot fname. And here's when arrow functions come in clutch. So all this while we were defining normal functions. If you are calling the normal function, this inside normal function is one that is calling that function. What if I don't want that? I don't want my this to be dynamic. I want my this context to be fixed. So when I'm saying person.say hi, inside the say hi function, this, when I'm calling this becomes person object. If I want another function to take this as the context in which it is defined. So if you want this context to be fixed by where it is defined, you would use arrow functions. So in this case, this over here is the person object. I can show that by logging it out. This is the logged out version. This is the line number 5 being printed out. That means this over here, when you print out line number 5, is the person object. And I want the function over here also to fix that. So I would, instead of defining it with a normal function, you would say it's an arrow function. And here's the difference coming. Arrow functions inherit this from where they are defined. It's also called lexically. The arrow function is defined over here. It is being called somewhere else, but the definition, when you have written it, happens over here in this line number 6. So just at this point, when the arrow function is defined, what is this? This is the person object. So in this case, this inside arrow function will also be lexically bound to the person object. That means no matter where it is being called, this will always result in the person object. That's why when we define it as callback, this dot first name, and you would see the magic over here when I save it. Previously we had hi am undefined as the output. Let's save it and check 1 second. Hi am Tom as the output. This is because this inside the arrow function is lexically bound when they are created at the function definition. The function is defined over here when set timeout is created. That means this inside arrow function always points to the person, because that is what this was at the point of creation of this arrow function. This is because arrow functions don't create their own this. They inherit this from the surrounding scope. Yeah, so arrow functions are perfect for stuff like that. For example, callbacks inside set timeouts, even in array functions like map, filter, for each, where you want to keep the outer this context. But here's a trap: don't use arrow functions when you want the function to have its own this. For example, if you do this, you would run into trouble. It says hi am undefined. Because arrow functions don't have their own this, they get their this from the surrounding scope. In simpler terms, ask yourself what is this when this function is defined, not when it's called. The calling is happening over here, but at the point of definition, inside this object, when the object has been defined and the function has been defined, this is at the point of definition of this say hi. The surrounding this context is window or global object. We can check that by having a property here that points to this. Now, if I print this, we should get the surrounding scope of the say hi arrow function. When I print this, you can see that's the window object. Here it ties very closely to how the context is being created. You learn this in the execution context. Only functions create their own execution context. That's when the execution context changes, and this also changes. So in here, when we are defining the object, all the properties, it's getting the values from all the properties. Then this is still the global or the window object. But when a function is run, it creates a function execution context, and that's where the this and the execution context change. And this is the exact same thing that's happening. Here, this is still the window or the global object. And say hi, since it's an arrow function, it does not create its own this context. It gets the this from the surrounding scope. and that has been fixed. Whenever we call it, doesn't matter how we call it, it will still be the window object. So let's take this a step further. Let's create a normal function. Inside here the context will change. So remember, function execution context when run, this becomes object which is running the function. I create a new function, new arrow function over here. And in here I will console.log. This dot first name, and then return this function. So whenever we are calling this function, I will get a function in return. I will call this function after getting returned. So in this case, to call the function, I would have to say person dot normal func. Remember, this normal func would return me the say hi function. So I would say, let's say const say hi from Tom equal to this person dot normal function. Again, function dot normal function will return the function, the arrow function. So while the function is being defined, this particular piece of code, this inside is the object which is running the function. So what is the object running the function currently? Person. That means say hi will get the context from that person object, surrounding scope. So this here is person. Although right now this is the person object which is dynamic in nature. So when I call the say hi function, say hi from Tom, it should give me hi, I'm Tom. Again, hi, I'm Tom. That's why this say hi, we are calling say hi from Tom, this particular function, from the global context. From the global context, still I'm getting the person object as this. This proves my point. This tells you that say hi, this is an arrow function that the context of which has been fixed when it is defined, and that is through the surrounding scope. So let's change this inside normal function, we can change the context. So let's change the context and check what happens. We can change the context by changing which function is calling the object. Let's have a const person2. F name would be something else. Let's say I'd say normal func, same. Let's have another function that will refer to the person.normal func. Person.normal func. That means this now normal func refers to the person.normal function. That means it gets the exact same thing, although as a reference, not directly copying it. Now if I say hi from Tom, say again, calling this would be the same thing. Person2, now person2 dot normal func, I will get say hi from P2. When I do this person2 dot normal func, now person2 is calling this normal func, which is again this thing. So now we have changed this context for this normal func. The context for normal func, this context for normal func depends on which object is calling that function. So again, now it's not the person, it's person2, which is dynamic again. And instead of saying hi from Tom, I would say hi from P2. So let's see what happens. Hi, I'm Hillary. So that's how we can use both arrow functions and normal functions in the way they are meant to. Normal functions are used as methods of an object where we want to preserve the this based on who is calling the function. Whereas for arrow functions, when it is created, it gets fixed. And this is amazing for things like callbacks and stuff because callbacks are called in a different context. That's why generally we tend to use arrow functions inside callbacks. So yeah, if you ever want to preserve this, arrow functions are your best friends. But if you want this to be dynamic or tied to the thing that calls the function, use regular functions. But what if you want to manually control what this refers to? And here's where bind, call, and apply come in. A revision for this binding for normal and arrow functions. This is dynamic and changes how the function is called. And this can be changed using bind, call, and apply. We'll look at that next. These are suitable for things that rely on the context being the object that is being called. Arrow functions, this becomes fixed when it is defined, not when it is called. They get their this from the scope in which they have been defined, and this is lexically bound and cannot be changed at runtime. It is great for callbacks and functions that you want to preserve the outer this. Next up, we want to manually control what is this inside a function. This is where all these three functions come in. We have call, bind, and apply. These are function methods. We call them on the function itself. These are used to manually set what this is inside a function. There are subtle differences between these three, although they can do the exact same thing. Here, look at the syntax, how it's being called. The function that you want to call, you say function dot call, and the arguments you give using comma separated values. When using apply, you give arguments as an array. The first argument will always be the this context that we want to keep in the function, and both of these, call and apply, they invoke the function immediately. When using bind, we have the function dot bind, and this context we passed as an argument. This returns as another function in which this context is now fixed whatever we have provided it, and we can again call it using parenthesis on the bound function. It does not immediately invoke it. Let's see that in action. I'm having a function greet over here. And we have a const person. If I directly call this function greet, this would be the window or the global object, because on the left hand side we don't have anything that is calling the method. Hi, I'm undefined. If I want to call this with a context of something else, I would say greet, the name of the function, dot call, and then give the this context, that would be the person. Now when I invoke it like this, the this context for the greet function will be changed to this person object, which has the first name as Charlie. So it will say, hi, I'm Charlie. Hi, I'm Charlie. Same goes with apply. The first argument is the exact same for both. And similar thing goes with bind. For bind, it does not immediately invoke it, it returns as a function. And now I can run the binded function in order to get the output. Hi, I'm Charlie. We can do exact same thing with all of these. The differences come up when there is a parameter over here. Let's have roll number. So if you want to pass in parameter using call, you give it as comma separated values. If you want to give parameter in apply, you give it as an array. You can have multiple different values in an array. And binded, you have to give it while we are calling that function. In binded, you have multiple options. You can either give it over here, or you can do it while calling the function. So let's first see while giving over here while binding the function. All three I'm getting proper outputs, roll number, roll number. And if I want to pass multiple parameters, you would do it over here in an array. For call, you would do it like this, comma, and then give all the values. And for bind, you can either do it like call, or you can use it here while you are calling the binded function. So either way works. And this is the use of call, bind, and apply when working with this context. And any of these don't work with the arrow function. Arrow function, the context is fixed when it is defined and nothing can change it. Even using call, bind, and apply, you cannot change the context for arrow function. Quick recap. Regular functions get their this from how they are called. Arrow function get their this from where they were created. Do not use arrow functions for object methods. Once you understand this, you'll stop getting weird behaviors and bugs, and your code will actually do what you expect. Keep practicing. See you in the next one.